The graph below shows velocity v versus time t for an object in linear motion. Which of the following is a possible graph of position x versus time t for this object? So we see from the velocity time graph that the velocity appears to be constant and positive for this first portion of the object's motion. Then the object begins to experience a changing acceleration that levels out to be negative here, and then that acceleration becomes a little bit more positive until the acceleration is 0 again, and the velocity is again constant. Remember that on a velocity versus time graph, acceleration is slope, and on a position versus time graph, velocity is slope. Okay, so let's see if any of these position time graphs represent the same kind of motion as the velocity time graph. So on our first position time graph, it looks like we have 0 velocity initially, since the slope is 0, and that already doesn't match with the velocity time graph. So this one is not correct. Next, it looks like we have a initially positive velocity, followed by a changing velocity that becomes a constant negative velocity, which does not happen on our velocity time graph. The velocity continues to change under a constant negative acceleration. So this graph is not correct. Next, we have an object that seems to start with a slightly negative velocity. Again, not correct, since up here we start with a positive velocity. In our next graph, it looks like we start with 0 velocity, since the slope of this line is 0, indicating 0 velocity, and again, that's not correct, since we start with a positive velocity on the velocity time graph, so this graph is not correct, which means that this graph must be correct, as it is the only remaining graph. As we see, the object starts with a constant positive velocity, so far so good. Then it undergoes a changing velocity, so that velocity is positive and gradually changes to become negative right here, somewhere in the middle, and that seems about right. And then that velocity levels out and is constantly negative for the remainder of the time interval. So that checks out and makes sense. So this is the best option for this problem.